We'll start with the concept of resource sharing. We have seen the concepts of examples of different distributed systems and various applications in which it is mandatory to go for distributed systems. Now we'll go for the concept of resource sharing. So when you talk about resource sharing, so what is meant by resource sharing normally? So in a normal network, the sharing of resources may be in terms of either hardware resources or the data resources. The hardware resources can be either your printer or any plotter or whatever it may be, or your data resources can be either files or it may be your search engines. So other resources can be your search engines. So here, whenever we are talking about hardware resources, so you can see printers, we can use the disk. So normally why we use these printers and disk is nothing but to reduce the cost, because as an individual user you may not require that much disk space for storing of your information. So much disk space is not required. Now you people are working with 1 TB hard disk. So out of that, how much you are using? So you may be using only 30% of 40% of that. So instead, if you are able to share that this space to others also, they can also maintain their information. So that means you are sharing your resource. Okay. So printer. So most of the times, a computer connected with a printer mostly will be using 10% of maximum 10% of its processing time. That means when the system is on and you are doing some processing, out of that maybe 10% of the time you may be using the printer. Other time it is sitting idle. It is not at all used. So it is always better to utilize that resource by somebody else so that it will reduce the cost. And the higher level resources, so it may be in terms of sharing the data or sharing the databases or set up web pages. What is a web page? It may also contain some data. Okay. So it may also contain web pages consists of information. Okay. So that is also part of data. A file may be having some information, a database may be having information. Okay. So here I'm not talking about the disks or the processors. I'm talking about only the data in the form of files, or it may be in the form of database, or it may be in the form of web pages. Okay. So whenever we talk about this resources, so these resources, when they are being shared across different computer users or different users of computers, so then it becomes a shareable resource. That means we are using, so here in addition to these resources, even processor can also be considered as a resource. But here, whatever discussion we are making, so processor is not going to be shared. The execution time of the processor is being utilized. Okay. Now, so normally the concept of resource sharing comes when you have a network of systems. That means when you are under a network of systems, it means that you are related to each other. That means you are closely working with each other. Then only you will be working under a network. Okay. So whatever resources that are available with any of the users under a particular network, if it is being shared, then you can utilize that resource and you can do your processing and you can reduce your cost. So on the other side, when you talk about a search engine, what the search engine will do, search engine on the web provides a facility to the users throughout the world. So it is being used by people who throughout the world, and they need not be in contact with each other. They may not know each other also. Okay. So this is the other extreme. So one extreme is only limited people connected with a simple LAN or something of that kind, and where they must know each other. They must know each other. They are under a single network. That means they are under a single network. So they should know each other, or they may be working in the same organization. But on the other side, if you talk about search engine, which is being used by extremely huge number of people throughout the globe, and they may not be aware of the other person who is using that. Okay, so these sort of two distinct edges are there, where one is limited to a smaller group of people knowing each other, and we have a larger, the extremely larger group where they don't know each other. Okay, so but in both the cases, we'll have the cooperation. That means unless I provide the data, the search engine can't search it. Okay, that means I'm also a contributor to that particular search engine. Okay, so the users who cooperate directly share the resources such as documents in small closed group. Okay, so the geographical distribution of particular users determines how the coordination among this group of people can be. Okay, so that is a major concern for geographic distribution of users. Now, what what sources we can share, or what services we can share? So we use the term service for a distinct part of a computer system that manages a collection of related resources and presents their functionality to users and applications. Now, normally you can see here accessing shared files through a file service. So I'm talking about the service also here. So how you can access the files from a shared resource? It is through file service. So we can send the documents to printer, which will take care of that. The printing service will take care of that. We can buy the goods through electronic payment. So the electronic payment service will take care of that. The only access we have to do service is via the set of operations that it exports. So whenever you require some service, so that particular service must be available to you, and it should be accessible to you. Once we have the service, we can do the corresponding operations. What sort of operations you'll be doing? Either you may fetch the data, or you may write the data, or you may delete the data. Okay, these are the different operations you are doing. So basing on the permissions that you are given with, you can perform any one or few of these particular operations. Okay, so whenever you are maintaining these particular information, distributed systems are physically encapsulated within the computers, and they can be accessed by other computers by means of communication. That means whenever you want to access a resource, we require some communication through which we can do that. So this effective sharing is possible through an interface that is called communication interface. Okay, this communication interface enables the resource to be accessed and updates them so that it acts reliably and consistently. So that is a major aspect here. Now, the terminology, we are going to talk about the terminology. So here, the term server refers to a running program. Server doesn't mean that it is a machine. Server means it is a running program which is on a network that accepts the request from a program which is running on other computer. Let us assume that I'm running a program and you are running a program. My program is making a request to your program. So when I'm making a request, what it means? So I'm making a request to provide some service, to perform some service, so that you will provide the service to me. So in that case, your program is an server program and my program is an client program. So your program is called server and my program is nothing but client. So here, whenever this sort of communication is there, the platform or the communication should be in such a response from the server should be promptly given, and the request made should be served within time. Okay, so in this case, that these particular two systems are said to be in client-server computing mode. Okay, so in this approach, what you are going to do, the requests are sent in messages from clients to a server, and replies are sent in messages from the server to clients. Okay, so this complete interaction between the client and server from the time when the client makes the request and when it receives the server's response. That means client made a request and server responded to the request with a message. This complete process is called remote invocation. I made a request. The request is taken by the server and it has responded to my request. That means it has served my request. It has I made a request to a server. So when I make a request, I am said to be client. The other side of the system, other program to which I have made a request is nothing but the server program. So that program has to respond to my request. So making a request to responding to the request, whatever process that happens is called remote invocation. Remote invocation. This is called remote invocation. So in some cases, a same process may be both a client and a server. So now whatever I talked about is two separate programs. One makes the request, which is called client, and another receives the request and responds according to that is called server. Now, in some of the cases, both client and server are going to be the same process. Okay. So the term client and server applies only to those roles played by the single request. So in that case, when client makes a request, okay, then it will be active and the server will be in passive mode. That means, you see, I'm saying that the same process will work both as a client and a server, but even physically there is a single instance of the program which is getting executed. Logically, it is doing as if there are two different programs that are running. Here you can see when in this sort of situation clients are active making requests and servers are passive. So why they are passive? Because unless the request is received, they need not do any work. They need not do any work. So once the request is received, the client will be passive and server will be active mode. So once the server responds to the request, server will once again will go into passive state and client will become active state. So here the server will run continuously. The server will run continuously. That means it may not be in active or it may be in active or passive state, but it will be running continuously. Whereas the client will survive or will be in a running state only when they are running. That means I made a request and the server has responded. There the client process is over. The client server communication is over. But as a server, when I call a particular process as a server, then there may be several requests that is coming from different processes. Then only I call the program as a server program, and it is expected to be running continuously. So let us assume that I have a print server. So I'm just giving an example. So print server, when I say, don't think printer as an hardware. So there is a program which will run so that the printer will be activated and the response of the printer will be as per according to my request. The printer will respond by printing the document onto the pages and finally sends saying that my job is done. Okay, so here I made a request to the printer service. So then the printer server will be active. Once the job is done and it has responded with a message, the service is being completed, the client program is no more there. But the server service is still available. Server service is still available. Now, Here the client and server, whatever you are referring to, they are referring to the processes rather than the computers. So whenever I make a request, I'm the client program, client process. I'll be called as a client. And the other process which is serving my request is nothing but the server program. So another process is making a request to my process. Now, in that case, the other program is nothing but the client and my program is server program. Okay. So here it is purely based on who has made the request and who is serving the request. Whoever is making the request is nothing but the client, and who is making the service or who is providing the service is nothing but the server. Okay. So whenever you are running a process, it may act as a client process and also as a server process basing on the operation which you are doing. If you are making a request, it is client. If you are serving a request, then you are called as a server process. Okay. So most of the distributed systems are written in object-oriented languages, and resources normally may be encapsulated as objects. So in object-oriented programming, you can see that all the resources are implemented as objects of different classes, and they are accessed by the client objects. Client objects. Any method of a class can be accessed through the objects of the class. So in that case, object is the client and your class is your server. Okay, client object invoking a method upon a server object. Okay, so most of these distributed systems, whatever we are talking about, they can be implemented by having an interaction of client and servers. Okay, so whatever major examples we are having, like World Wide Web or email server or networking printers, all these things will fit into this particular distributed systems, where I can talk in terms of clients interacting clients and servers. Okay, so in World Wide Web, if you consider, your browser is nothing but your client, and it communicates with the web server and makes a request for the particular web page. Okay, so when a web page is request, the web server will provide the web page as an return. That means it provides the access to that particular web page so that you can view that particular web page. Okay, so that is the service provided by your web server. So now we'll going ahead with what are the issues or challenges we are going to face in implementing distributed systems. So as we have seen the several examples of distributed systems and the aspects and the issues that are to be considered as a part of distributed systems. So keeping in view of all those scope of the distributed systems and the issues that we are going to have, while doing the design of these particular distributed systems, we have to concentrate on several characteristics like or several we have to keep in view of the challenges that we are going to have as a part of implementation of distributed systems. So the first and foremost one is heterogeneity. As we have discussed in several cases, whatever systems that, when we discuss about distributed systems, we have discussed that the set of autonomous computers may be different in terms of the architecture of the system, the operating systems, the application programs you are using. They may be different from one computer to autonomous computer to another as autonomous computer. So in these sort of things, the internet enables users to access the services and run applications over heterogeneous collection of computers and networks. So heterogeneity may be in terms of the networks that we are going to use, the computer hardware, the operating system and the programming languages you are using and the implementation by different developers. Okay, so in terms of networks, so that means when you are connecting all these different connected autonomous computers, some of them may be under LAN and some of them may be in WAN and some of them maybe having an another network architecture, or each some of these systems are of different hardwares or architectures. They may use different operating systems. Some may be in Windows, some may be in Unix. Okay, so all these heterogeneities we have to keep in concern while maintaining a distributed system. So what are the major problems we are going to have? So let us assume that I'll talk about the hardware. So maybe I think in second year when I'm taking some of the subjects, I told you that there are two formats, big Indian format and small Indian format, Indian, ENDIAN. So these are nothing but the data representations and basing on the byte ordering, they may be classified into big Indian format or small Indian format. So some architecture systems may follow big Indian format and some architecture systems may follow small Indian format. So it's simply reordering of bits. Normally you know that when you are storing an integer, an integer, let us assume that it is taking 2 bytes of memory. That means 2 bytes are there to represent an integer. So whether these 2 bytes, so the upper byte and the lower byte, if I call that, whether they are stored in the same order in the memory or they are stored in reverse order. That means lower byte is stored first and upper byte is stored next. So basing on that, in different architectures, in some of the architectures they are stored in the same sequence, but in some of the architectures they are stored in reverse sequence. That means lower order first, lower byte first, then higher byte. So depending on the architecture of the machine, this data storage is going to be there and the ordering of these particular bytes are going to be there. So that is also one concern. And may have different operating system. So once you go for different operating system, the APIs of this particular operating system for implementation of this internet protocols is going to be different. Okay, you may use different programming languages, and each language we know that they have different implementations for characters, data structures such as arrays, records, and so on. So we know that simple example in C language always we used to say that a character requires 1 byte of memory, but if you go for Java, so it is ASCII format here, there it is Unicode format in Java. So it may be different in some other language. So the variations in terms of data representations and the how the data structures are going to be implemented with. So if you take C language, so the array may be stored in one form, and if you go for Python, it may be considered as a different format. So like this, there will be variation from one language to other language. So this is also a concern for you. This is also a part of heterogeneity, and the way in which the communication is going to happen. There are some common standards for communication purpose. So they may have different standards for communication. So this is also part of heterogeneity. So in addition to that, so there is some software at the middle layer which we call it as middleware, a software layer which provides the programming abstractions. So why we require programming abstractions? Because this programming abstractions will provide an abstraction of which network you are using, which hardware you are using, which operating system you are using, which programming language you are using. All these things are not at all of your interest. So these are not of your interest. What is happening at the background as a user, you need not know about all these things. So this middleware is one such tool which will resolve the problems of heterogeneity. Okay, so this middleware has to provide a uniform computational model which will be used by the programmers of the servers and distributed applications. So the middleware resolves the problems that are there with respect to your heterogeneity. So in a distributed system, we use this particular middleware to resolve the issues that may arise, due to this heterogeneity in terms of networks, heterogeneity in terms of hardware of the systems, heterogeneity in terms of the operating system that you are using, and heterogeneity in terms of the programming languages you are using. And on the other side, so whenever mobility, we have to introduce the concept of mobility. That means a code which is developed in one language should be compatible and implement. You must be able to implement on the other architecture system. So that's why. So the concept of mobile code refers to the code that can be sent from one computer to another and run at the destination. So here, if you take the example of Java, we have Java applets and Java virtual machine. So the mobile code purpose is it is used to run on heterogeneous computers, irrespective of the architecture of the machines. We are able to run the Java program which is developed in one architecture computer, and it is portable on other architecture computers. So this particular concept you have learned when you are introduced with the concept of Java portability. The Java class file is portable to any of the architecture machines and any of the operating system, irrespective of the architecture of the system or what you call it as operating system on which you are running. Still, you are able to use this Java class file, which is machine independent. Okay, so the code that is possible to execute on any hardware. Okay, so here you can see, as I said, the Java class file is portable to any architecture machine. So what the virtual machine is doing, the virtual machine provides. So that means once you take the class file and when you go for execution on another architecture machine, at that level, it will be generating a code with respect to that hardware and executes. That's all. So the class file is portable. The class file is portable. Okay. But C, if we take the language C, C is not portable to different architecture machines. So we have to do little modifications. Okay. So the middleware and the code mobility will resolve the issues whatever you have in terms of either network or different architectures, or it may be operating system or the programming language. Okay. Now, openness. What do you mean by openness and why we are required with? So here, when you talk about openness, you have to address the issues like, now let us assume that I have some services and services are not sufficient. So what I need to do, I need to provide more components so that there will be extended service. The services, more services can be extended. So I have only one printer for 50 systems. Now it is doing good. Now I added another 50 computers to my distributed system. So, but still the printer is the same, only one printer. So that same printer may not be in a position to provide services for all the people and doing services for all the requests made by the people. So that means it is overburdened. Then what I need to do? I need to attach a new printer, and once I attach the printer into the distributed system, it should be accessible to everybody. That's all. That means if the old printer is busy with some other work, then it should be routed to the printer which is newly added. So this should happen dynamically. Okay. So this should happen dynamically. So that's what it says. New components have to be integrated into existing components so that the added functionality becomes accessible from the distributed system as a whole. Okay. Components may always be running on the same platforms. May not always be running on the same platforms. For example, if you take different banks, they may work on different architecture servers, bank servers, and the database they are using to store the information of the customers and their account details. They may be using two different types of databases. So if you take two banks, one may be using Oracle and another may be using some SQL server. The data formats are different. The architecture of the computers or server computer is also different. Okay. So in this case, even the programming, so one may be implementing that the web application using either ASP or ASP, and another may be using JSP. Okay. So in R, some may be using PHP. So like this, the applications are also different. They may be under different network architectures. The type of the host that we are going to have may be different architecture machines, different databases, different programming languages. But still, when you are approaching a teller machine, maybe it may not be of your bank. You may go to other bank's ATM. Still, you are able to withdraw the amount. So, what is happening here? The collection of these different the distributed systems, combinedly I will call it as a banking distributed system for banking purpose. Distributed system for bank. So any teller machine can serve your request to provide you the automatically provide you the necessary amount. Okay. So even your card doesn't belong to the bank, you can go to the ATM of that particular bank and you can withdraw your amount. So it should serve your purpose. So even they are of different architectures, still they serve the request of the users. Okay. So as I said, the architectures may be different, the database they are using may be different, the application program which they are through which they are trying to access the information may be different, the network they are using may be different, the network architecture, all these things may be varying. That's why it is the best example for an heterogeneous integration. This is the best example for heterogeneous integration. So just I have shown an example where a Windows 3x PC have to be integrated with components running on SunSpark station. So in SunSpark, short integers on the SunSpark are 64-bit, while it is only 16-bit. In C language, we have learned an integer takes 2 bytes, but in SunSpark, it used to occupy 64-bit. That means it is 8-bit, 8 bytes. It is 2 bytes here, and it is 8 bytes here. So here, as I told you, while storing of information also, the 2 bytes which you are talking about on a normal PC will revert. That means it stores as a big Indian or small Indian format. So, but still, when you are integrating all these different systems into a single distributed system, they are serving the purpose irrespective of the heterogeneous integration. Next comes the other issue is security. So when we are talking about security, as we learned that in distributed systems, send request to access the data, and that is going to be served and managed by your servers. Okay. So whatever you are asking for, it may be for for data or for a resource. So normally, the best example if you take, because of this pandemic, now we are doing telemedicine. So if they want to access, now let us assume that if the doctor wants to have access to the records of the patient records from the hospitals. Okay. So in that case, what sort of patient information should be given? So normally the patient, when you are going for a particular hospital and visiting yourself, So then you may be given with your phone number, your email ID. In addition to that, now they are asking for whether you have any what you call it as uh, health insurance policies. All this information is available in the student patient database. But as a telemedicine person, I need not have all that information. What I am required with is what are the symptoms, what are the test reports. Only that should be accessible to the doctor. The other information need not be provided to the doctor. That means out of the patient information, only few of the information which is meant for diagnosis should be made available to the doctor. Remaining information should be marked. Marked means they should not be provided with access. So in a distributed system, when you provide access to your data or records, only basing on the credentials of the person, you may provide complete access or partial access or no access. Complete access means you have everything with you. You have complete data about the particular. Partial data means it may be only patient information, that is diagnosis information, may not be of personal information. Okay. So other example is, so normally whenever I make purchase of products from e-commerce, so everybody knows about this. So when I make a purchase or basing on the interest of, so here I'm just trying to correlate. I'm just trying to correlate the things. Normally whenever you go for either your Amazon or whatever other e-commerce websites we are having, Flipkart, eBay, and all those things. So whenever you want to buy a product, what you will do? You will search for the product, and while in the process of searching, you may show some more interest. That means, on a particular item, you may look into more details. So this search process, whatever you are doing, and the pages in which you are getting into much detail, all this data is going to be maintained by your e-commerce websites. So basing on that, now let us assume that I'm just browsing through the list of products that are available, and initially I told that I have mentioned that I want to look into mobiles, and there, because my interest is I don't want to go for other products other than Samsung or something else. I've checked only those, and I'm searching through all the items. In that, 2 or 3 products are within my economy range, or purchase capability range. So I have searched through those particular items in detail. That means what is the configuration of those, how much memory is there, RAM, and all those things I have searched through, and I just came out. So this total search process is going to be maintained by your e-commerce applications. Every user search process is maintained by your e-commerce applications. So basing on that, the new messages will be coming, new mails will be coming. So if you have allowed that e-commerce application to send product promotion applications, product promotion messages, you will get those messages which are related to the search which I have made, or the items on which I have shown interest. That means where I have gone into much detail. So all these things are to be monitored. So here, this information is an add-on information that you are providing. That means by you making your searches, an add-on information is going to be provided to the e-commerce applications which are maintained. But these searches are not visible to others. Okay, so it may be the data secrecy. Data secrecy means some of the details you should not reveal to anybody. You should not reveal to anybody. And the personal privacy, some of them are required to be, you have to provide privacy basing on the personal specifications. Personal specifications. So let us assume that I'm specifying that I don't want to receive any sort of messages which are promotional messages. I have my email account. In that, I can specify that I don't want to receive any promotional messages. That means there is a personal information. Or I don't want, or whatever success I'm making, I don't want to maintain that information. I don't want the e-commerce application to maintain that information. That sort of privacy also you can place. Okay. So, in the process of providing the security, so next step is security, privacy and security. We talked about privacy. Now we'll talk about security. Security is maintained using an authentication process. Okay. So whenever a particular remote user is trying to connect to your system and trying to access some resource, they should be properly authenticated. They should be properly authenticated. The access to the resources from an other person should be properly authenticated. Then only the security will be there for your resource. Okay. So the major challenge that we are going to have here is when you are performing because of this privacy and security, because of this privacy, some of the data is not visible to the outside people. That means you are not at all accepting the request that is made to access the privacy data. And sometimes because you are applying authentication, process, the other user may not have access to your data unless you provide an authentication profile. Okay. So here this leads to whenever you don't provide the authentication profile, username and password for your accessing the service or so that particular access to that particular service automatically leads to denial of service. Okay. So in the modern distributed systems, denial of service because of this authentication process is the major concern. Okay. And another issue is mobile code. As I told you, the mobile code is nothing but the portable code. The portable code. So when I say portable code means the code is not in the source format. It is not the source code. It is an intermediate code or the binary code which is portable. So if you take an example of Java, so Java, your original file will be there .java, and that will be converted into a class file which is portable across all the platforms. But this binary code, whatever is there as a part of your class file, when you want to port onto the other system and execute it, so normally it will lead into an error message saying that some unidentified code is going to be run. So then if you are accepting that, then it will go ahead with execution. And then we talk about scalability. I think time is I'll just stop it here for today. This challenges of distributed systems. So if you have any